In this video, we're going to take a look at how to write ionization equations for acids and dissociation equations for bases. And there's really three main steps to doing that for each of them. First of all, for the acid, you're going to start off by writing the acid as aqueous. You're going to draw a single arrow for a strong acid and a double arrow for a weak acid. And then you're going to write H plus the ion of the negative charge, H plus the ion that's associated with the H, with a negative charge for every H plus removed. So every time you remove an H plus, you become more negative. Make sure it's -1 for removing one H, -2 for removing two H's, so on and so forth. So we're going to go ahead and do some examples. We'll do the hydroiodic acid example and then the acetic acid example here. Just some references. We have our strong acids over here. And basically whatever's not on here, plus those other exceptions we saw earlier, HClO3, for example, HiO3, for example, those are all strong acids as well, but everything else would be considered a weak acid, and we'd have to use our double arrows for those. So let's go ahead to our handout and do some practice problems together. So write an ionization equation for hydroiodic acid. Remember this hydroiodic acid, if you need to review how to write formulas out, this is a binary acid. That's going to be HI. If you need to review it, make sure you go back to our unit 2 where we saw naming and writing formulas for acids. So we're writing out the acid as AQ. And hydroiodic acid, remember, is one of the strong acids that you had to memorize. HI there. Okay. So you can just make a single arrow. You can write H plus. You can put AQ for that. Plus, then the ion that's left over with it is I minus AQ. Now in reality it's -1 and +1, and that's our ionization equation for the acid. You could have also written it the long way, but I don't mind the short way, but essentially you could have done HiAQ plus H2O liquid would produce I minus AQ plus, so the HI gave away an H to water and it made H3O plus 1 AQ. This and this are basically the same thing. It's just the shorter form that we wrote down. So those are two ways to write ionization equations for a strong acid with the single arrow. Now we have an acid called acetic acid. This one you may not know the formula for, so if there's some weird acid, a weak acid that you don't know, I would give you the formula for it. So acetic acid is CH3COOH. And I'm going to write it the simple way first. So we'd still write it as AQ. We would put our arrows, but they're double arrows to indicate that it's not 100% ionization. I'd remove one of the H's. The one at the end is the one people usually remove. That's the one that would be the acidic H there. So it would become CH3COO. If you remove one H, you become -1. That's AQ still. Plus the H plus in the solution. Now, it's not really H plus, it's actually H3O plus. So if you want to write this in the more accurate, longer method, which is not necessary, but if you want to do that, you could do CH3COOH AQ plus H2O liquid. We would make our double arrow still. This is the acid, so it would give away its H to the H2O. I just showed that arrow there to indicate that you wouldn't actually have to put the arrow there. So we'd still get the CH3COO minus AQ, but we'd write the H plus as H3O plus AQ. Now I'm putting the 1 there just to show you that we removed one H, so it's, that we have an H, so it's +1, or we removed an H, so it's -1. In reality, you could just leave it as minus, plus, because it's 1. But if it was a different number, you'd have to put, -2 or +2 or whatever be the case. So that there would be some examples of writing some ionization equations for hydroiodic acid and acetic acid. There's some videos here that go over those concepts in some more detail, but you should be able to do that for most acids that I give you. We'll do one more example. So let's say I wanted you to write an equation for the ionization of HF. So I need you to recognize that HF, for example, it's not on our strong acid list. It's not there or on the list from the previous slides that we saw here. So from the strong acid list here, it's not there either. Hydrofluoric acid is a weak acid. So I need you to write out your HFAQ. You'd recognize it's a weak acid, so it has our double arrows. And you can draw the double arrows this way or the other way, where we had full complete arrows as I've shown there. That would become H plus AQ plus F minus 1 AQ. And if you want to write the long way, you'd have so HF AQ plus H2O liquid, double arrows still, becomes F minus AQ plus H3O plus AQ.